Yes. Yeah, good evening all. Right. In the last class, why PySpark? It's a Python API to use Spark for running distributed SQL, creating data pipelines, ingesting data into database, working with the graphs, working with data streams. Spark is an open source distributed cluster computing framework with in-memory computing with parallel process style used for large-scale data processing. Spark advantages: in-memory computation, distributed execution, flexible parallel process, very high-speed process, multi-language support, good for iterative algorithms, supports advanced analytics, transformations can be reused. Okay. Next, I need to discuss something about RDD. RDD, resilient distributed data sets. Resilient distributed data sets. Resilient distributed data sets. RTD. Spark data objects are called as RTDs. Understand here? Spark data objects. RTDs. RTDs are subdivided. RTDs are subdivided into partitions. These partitions are distributed. These partitions are distributed across multiple RAMs. Multiple worker nodes. These partitions are distributed across multiple RAMs of multiple worker nodes of Spark cluster. RTD, resilient distributed data sets, the programming style, RTD programming style. RTD programming style is data flow. Its programming style is what? Data flow. Data flow. Data flow is a sequence collection of pipes. Data flow is a sequence collection of pipes. Sequence collection of pipes means RTDs. A pipe is any data operation. A pipe is any data operation. A pipe is any data operation. The operation can be loading data. The operation can be loading data, transforming data, filtering data, sorting data, merging data, etc. The operation can be loading data, transforming data, filtering data, sorting data, merging data, etc. At each pipe, the transformation or filtering will happen in Spark. In Spark, data flow executed. Data flow is executed in sequence. Data flow is executed in sequence. In sequence. That is RTD by RTD. That is RTD by RTD, one after the another. One after the another. With in-memory computation, and persistence feature. So in Spark, data flow is executed in sequence, that is RTD by RTD, one after the another with in-memory computation and persistence feature. Persistence means already executed transformation results we can reuse it. Two RTDs never execute in pattern. Two RTDs can never execute. Two RTDs can never execute in parallel. Never execute in parallel. But if a RTD divided into 20 partitions, then these 20 partitions are executed in parallel. If RTD divided into 20 partitions, then these 20 partitions are executed in parallel. Okay.
Excuse me, I have a question here. Is RDD means it's kind of a table structure or what it is?
RTD, okay, it is a Spark data object. Okay, 1 second. I'll show you. Okay. Spark context dot text file. Okay. File path. Whenever a file is loaded by using Spark context, RTD1 is created. RTD1 is created. How RTD is created means a file. If you load a file, if you're loading a file using Spark context and RTD, just like a collection, it will be just like a collection of rows. It's like collection of strings. RTD is like a collection of strings. It's like a collection of rows, records. So how many in this file, if you think there are 10 records, the 10 records will be there in this RTD also. If 1 lakh records, 1 lakh records will be there in this RTD. It's not like a table structure. It is also a Spark, it's a Spark object. From a file, this RTD gets created. Okay. On this RTD1, if I perform any filter transformation, filter based on condition, I want only city equal to Hyderabad. Only the records of Hyderabad. So the output, the result, whatever you get is also an RTD. RTD2 got created from RTD1. Understand here? Initially, only no RTDs. First, there is a file. From that file, RTD created. On that RTD, perform any filter transformation. The result is also an RTD. Here, if you got 10 lakh records, if Hyderabad records are only 2 lakhs, RTD2 will have only 2 lakhs. So this RTD1 divided into multiple partitions. One RTD, if you have got like GBs of data, TBs of data, this RTD size is TB, divided into smaller parts. Partitions, we say that partitions stored across multiple systems and are processed parallelly. RTD1 filter, you got RTD2. Again, on this, if you perform any transformation on this RTD2, that some map transformation, mapping each employee's salary by adding 5,000 as bonus. So you're mapping that to each and every element. So from this, RTD3 is created. RTD3 is created. So in this way, the output, but if you are performing a transformation on an RTD, the result is also an RTD. On this RTD3, we perform some grouping activity, group by operation. Here we have got group by key. Group by key, we say. If you perform some group by operation, then RTD4 is created. RTD4 is created. In this way, one by one RTD keeps on creating, keeps on generating. So the output of RTD2, what is the input to RTD2? RTD1. What is the input to RTD3? RTD2. Means RTD3 got created from RTD2, RTD4 from RTD3. Yes. RTD5 equal to again RTD4 dot some mapping such a way that each and every employee name starting with uppercase character. Finally, if you perform RTD dot collect, if you perform some action, means there are some actions, collect, count, take. If you perform, whenever you say this RTD5 dot collect, then from this RTD1 to RTD5, from RTD1, RTD5, they will be loaded, they'll be computed one by one, right? Yes. See how this computation of this RTDs is going to happen, Spark objects, right? Yes. See, where this RTDs gets loaded, everyone. I want the sessions to be more interactive, everyone. It's whether your answers are correct or wrong, keep responding, right? Everyone unmute yourself and try to respond. Where these RTDs are getting stored? Where
The
this
cluster
RTD
RAM.
in cluster RAM. So here, if I say RTD.collect, RTD.collect means what happens? Directly, don't think that only this RTD5 will be executed here. Whenever you are collecting, right, RTD5.collect, you are collecting the data of that output of this RTD5. Not only RTD5, first RTD5 to compute or to execute, it has to, RTD4 should be available. On that, if you perform some mapping operation, then only this RTD5 gets created. For RTD4 to create, RTD3 should be there. RTD2, RTD1. So whenever you say this action, this statement, right, it executes from the root RTD to the current RTD. How many RTDs are in the RAM now? Hello? Everyone, how many RTDs are in the RAM now after performing this operation?
5.
One,
See,
I think.
understand carefully here. You are storing the data in the memory RAMs. Why Spark has got very high speed as compared 100 times faster than the normal disk processing. Why it is 100 times means data storage and data processing both happening in the memory level. That's why we call it as in-memory computation system. In-memory computation. Because of this in-memory computation, Spark has got very high speed. See, even Hadoop is got a distributed execution. Even Hadoop has got parallel processing. Even Hadoop has got what, but only thing is Hadoop doesn't have in-memory computation. So Hadoop doesn't have, Spark has got in-memory computation, storing and processing in the memory level. So here, whenever we are dealing with Spark or these things, right? For big data operations, for huge data, for big data, don't think like KBs or MBs of data. So here for GBs or TBs or petabytes of data execution. So you don't think like one file or this file will be having GBs or TBs of data or petabytes. Here RTD size also will be too large. RTD size also will be too large. Means assume that one RTD size is like 2 TB. 2 TB, this RTD1 size. 2 TB, maintaining the 2 TB RAM, right? We need to maintain the 2 TB RAM. Just a second. Fine. So where this all these 5 RTDs are loaded, where these 5 RTDs are loaded means, see already one RTD size is too large, it's too big. For a single RTD only, if you want to accommodate a single RTD also, you need to have large RAM capacity. You need to maintain huge RAM capacity, right? But for this 5 RTDs to load into the RAM, right, it will be very much complex to accommodate this many RTDs at a time into the RAM. So here, what is happening in this RTD computation? This RTD1, that too single RTD, see this RTD1 cannot be stored in a single system, single RAM of single system. Means 2 TB or like 10 TB RAM you cannot maintain for a single system. So your RTD will be divided into multiple partitions, and those partitions are distributed across multiple RAMs of multiple worker nodes. So here RTD divided into 20 partitions, you think. These 20 partitions are executed in parallel, right? If RTD divided into 20 partitions, the 20 partitions stored in 20 systems, 20 RAMs of 20 systems and executed parallelly. Okay, so this RTD is stored across multiple systems, multiple RAMs of multiple worker nodes. That output, whatever you get, is taken by this RTD2. So here, RTD one by one RTD will be loaded into the RAM. When RTD2, just observe this flow, how it is going to be. Okay. See, this is RTD1. Understand here, this is RTD1. RTD2 is there. RTD3 is there. RTD4, RTD5. 5 RTDs. How this RTD got created from a file? File is a very huge file. We'll be dealing with huge files, that big, huge data, big data. And if you perform any transformation on this R1 dot filter, so the output, whatever you got, R2. The output of R1 is the input to R2. Okay, now R2 loaded into the RAMs, R2 loaded into the RAMs, and R2 computed, R2, and it's all its partitions of R2 loaded into the RAM and executed. Means again, you cannot keep on accommodating all the RTDs in the RAM so that there won't be any space for the incoming RTDs. There won't be any space for the incoming RTDs, right? If your data flow is a very big flow, if you have got some 20 RTDs, 20 transformations, if you are performing, so then the upcoming RTDs, there won't be any space in the RAM. So that's why what is the resilient distributed data sets means, whenever RTD2 loaded and computed, when R1 output is collected by R2, when R2 is loaded and R2 and its partitions, everything they are loaded and stored across multiple systems, R1 gets removed from the RAM. R1 and its partition, everything gets removed from the RAM. Similarly, the R2 output is taken as input by R3. How you got R2 dot map? Then you got this R3. The output of this is given as input to this. Now, when R3 is loaded and computed, R3 and its partitions all loaded and computed, R2 is going to get removed from the RAM. When R4 loaded, computed, R3 going to remove from the RAM. Once, okay, R5, the output of this R3 taken by R4, this output taken as input by the next flow. Means it's a data flow, sequence collection of 5. The output of 1 will be the input to the next. When R5 loaded, computed, then R4 is going to get removed. Once that R5 output is collected, once the R5 output is collected by the client, finally the R5 also removed from the RAM. R5 also removed from the RAM. So now how many RTDs in the RAM? After the total execution is completed, how many RTDs in the RAM?
0.
0 RTDs, right? No RTDs in the RAM. You can trigger the next flow. You can trigger the next flow. Again, the next flow, RTD by RTD, it gets loaded and the final output will be collected, and there you won't see no RTDs in the RAM. That is how this computation of this RTD is going to happen. Otherwise, what happens? All the once you come to this, 5 RTDs will be loaded into the RAM. That much space won't be available. So that one by one loaded and one by one will be removed from the RAM. One by one loaded, one by one loads, computes, removed from the RAM one by one. Finally, no RTDs fill the RAM. so that for the next data flow to execute, the RAM will be free now. Now you can make use of that RAM. But observe this flow, right? Observe this flow. Just understand this. I said in Spark, there is one more feature called persistence. What is that? One more feature called persistence. What do you mean by persistence? Persistence means already executed transformations directly you can use it, no need to re-execute again. You executed 50 RTDs. 50th RTD output should be used by 3 flows. Yesterday, okay, you have used one flow. Second flow, okay, you want to, again, if you want to execute the second flow, but in that, again, if you want to, no need to execute again the first 50 steps again. Directly from the 51st step onwards, you can execute, right? That is what I'll be discussing in brief about that persistence. But before that, try to understand this RTD's data sets computation within the RAM level. So there is a flow like this. Everyone try to check this and try to respond. R1 is there. R2 is there. R3 is there. From here onwards, R3, R4, R5, R6. I'm taking a small flow as of now. R7, R8, R9. This is the flow. How many flows are there here? 3 flows. Flow 1 is there, flow 2 and flow 3. Understand here, Spark is lazy evaluated. Spark is lazy evaluated. It's not active evaluated. Which one is better, active evaluated or lazy evaluated? Lazy evaluated is, what do you mean by, okay, a labor example. What do you mean by late active evolution, lazy evolution? For example, daily you are reading this, whatever topic, right? You are reading, immediately reading that day itself, or whatever practicals that day itself you're doing. That is what active evolution, immediately. What do you mean by lazy evolution? After 1 month, if I keep an exam, then only you start reading from the first to the last. Whenever I keep exam after 1 month, from the first day to 30th day, you will read. That is what lazy evaluated. Which one is better means lazy evaluated. Means here in Spark I'm talking. In Spark, lazy evaluated, how it is means whenever you perform any action, then only the data flow executes. Until then, it won't execute. Just like normal in programming languages, you see functions, right? Functions, you will define it, but until you make a call, they won't execute, right? Until you make a function call, then only the function executes. Here also, if you are making any action, then only the entire data flow executes. Until then, it won't execute. See, this is flow 1. From R1 to R7 is the flow 1. R1 to R8 is the flow 2. R1 to R9 is the flow 3. Same is flow 1. Flow 1 has got R1, R2, R3, R4, R7. Flow 2, try to say R1, R2, R3, R5, R8. Flow 3, R1, R2, R3, R6, this R6 and R9. Flow 3, 3 flows are there. Understand here, I want to execute the flow 1. I want to execute the flow 1. Data flows, right? Here everything in Spark data flow language. As I was saying, Pig and Spark both are data flow language. But Pig entirely converted into Hadoop MR MapReduce shop. But MapReduce is bad, I said. Flow 1. If I want to execute flow 1, I need to perform action on R7. If I perform some action on R7, from R1 to R7, they get loaded one by one and executes. I need to say R7 dot collect. Whenever R7 dot collect, if you say collect is an action, count is an action, I'll discuss one by one what are the various actions available. Okay. First, the flow starts from R1 to R2, R2 to R3, R3 to R4, R4 to R7, right? Understand this flow. R1 loads computes, R2 also loads computes. Once the execution of R2 completed, R1 gets removed. When R3 loads computes, R2 gets removed from the RAM. Similarly, whenever the next one is ready, the previous one gets removed. Once the output is collected, this last RTD output is also removed from the RAM. So how many RTDs in the RAM? No RTD in the RAM. Similarly, to execute flow 2, what is that flow 2? R1, R2, R3. Try to respond everyone. R5, R8. So this is the second flow. Flow 2 is this. To execute flow 2, what I should say? Action. If you say action only, then that entire will execute. On which RTD I need to perform action?
R8.
R8 dot collect entire thing. Then collect the output of R8. One by one RTDs will be loaded. Once the next one is ready, the previous one gets removed. Next one is ready, the previous one gets removed. Yes. Here also, once that R8 output is collected, no RTD in the RAM. Okay. But observe this commonality between these three flows. What is the commonality you observe between these three flows? Here also R1, this one, you are talking about this flow. R1, R2, R3, R6, R9. Whenever the next one ready, previous one gets removed. Whenever the next one loaded, computed. When a final output also collected, no RTD in the RAM. No RTD in the RAM. Now observe here, okay. But what is the commonality in the three flows means? First three steps are common in all the three flows. First three steps are common in all the three flows. R1, R2, R3, R4, R7, R1, R2. Okay. In all the three flows, first three steps are common, but still all the flows are re-executing again and again. So you are executing again and again. What is the drawback in this flows means? In the flow 2, again you are executing from R1, R2, R3. In all the three flows, even though already you executed R1, R2, R3 here, again you are re-executing here. So what you need to do is identify the RTD whose output is commonly used by multiple flows. Identify the RTD whose output is commonly used by that RTD you persist. So I'll say R3 dot persist. Whenever you say means this R3 will be persisted. What do you mean by persisted? What do you mean by persistence means making the RTD available in the RAM only. Even though the next RTD is ready, yes, persisted RTD won't be removed from the RAM. It will be available. If it is available to give its output to many other flows, if you are persisting it. Okay, check it now. So which RTD you will be persisting means whose output is commonly used by multiple flows. So here check with this, what is the importance of persistence if you are persisting? Here the same diagram you see R1, R2, R3. This is the flow, and this one you persisted. R3 dot persist. Whenever you persist, what happens you observe? Execute the flow one. If you're executing the flow one, R1, R2, R3, R4, R7. R7 dot collect or action you say. The flow begins from that R1, R2, R3, R4, R7. Whenever the next one is ready, previous one gets removed. Whenever the next is ready, the previous gets removed. Next one is ready, the previous one gets removed. And here R3 won't be removed, sorry. Whenever R4 is ready, R3 won't be removed because R3 is persisted. Persistent means even though the next one R4 is ready or computed, R3, the persisted RTD won't be removed from the RAM. Next R7, R4 gets removed. Once the output is collected, this R7 also removed from the RAM. Now, how many RTDs in the RAM? Hello? How many RTDs in the RAM? Everyone unmute and try to respond.
One.
One RTD, R3 is available, right? R3 in RAM. Now execute the second flow. Flow 2 you execute. R8 dot collect, if you say what happens? First it will check. R8 input is from where it has to start the flow, it will check. R5 input is R5 input is R3. R5 input is R3. R3 available in the RAM. R3 available in RAM. R3 available in RAM. R3 available in the RAM right here. Means R3 is ready to give its output. No need to again execute R1, R2, R3, right? Directly R3 output you take and compute R4, sorry, R5, R8. This is the flow. No need to re-execute R1, R2, R3, only R5, R8. Here if you observe, when this is ready, R3 won't be removed. When R8 ready, this will be removed. When the output is collected, this also gets removed. Once understood, the flow is decreased. Whenever you say flow 3, in the case of flow 3, the same thing, R9 dot collect. Try to say, first we'll check R9 input is R6. R6 input is R3. First it will check from where it has to start the flow from the beginning or from the, if any RTD is available in the RAM. So the flow starts from R3 because R6, R3 available, R3 in RAM, right? R3 in RAM. So R3, R6, R9. When R6 is ready, R3 won't be removed. R3 won't be removed, right? It will be there. When R9 ready, R6 removed. When output is collected, this also gets removed. Here also, in this case also R3 in RAM. Here also R3 in RAM.
I have a doubt.
Yes.
So let's say R3 is in RAM. So when R6 is processing in the RAM, will there be an issue with the memory, out of memory execution or something?
So whenever you're persisting in RTD, right, you will see the RAM capacity. We will be seeing that whenever you persist, you are making it to available in the RAM, means you need to see that much of RAM should be available. Means It's not, even if you have got a very good RAM, huge RAM, right? Even you can persist to 2 RTDs. If you have got a good RAM, means if you have got a very big flow, like check it in this way. R1, R2, so on, R50. R50 output used by multiple flows. You are persisting it. R50 output is used. So first, the first flow should execute compulsorily. At least one flow should be executed, because this to persist this R50, all this. The second flow onwards, they can make use of R50 output. No need to execute the first 50 steps. This is the second flow, right? And this is the third flow. From the second and third flows, R50 output is used by 3 flows. Second and third flows make use of this R50 output. No need to execute the 50 steps again, right? In the second and third flow. That is what the advantage of persistence. And whenever R50 persisted, means it will be in the RAM, and R6 will be loaded and computed in the RAM. Both RDLs will be in the RAM. So that much RAM capacity should be maintained. Somewhere like if you see R20 output also used by multiple flows, that also if you want to persist. If you want R20 output also used by multiple flows, that also if you want to persist, see that before persisting your RAM memory, it should be able to accommodate. If you have got a good RAM only, you can go for multiple RTD persistence. If you have got a RAM is low, you cannot go with multiple RTDs. Even single RTD also, if it doesn't have that much memory, yes, you cannot.
So suppose we are going to persist, is it programmatically or just by saying collect the intermediate steps will be
This here I've given, this is okay. Here what I was saying here, if you observe in this case, this is just a name I'm giving. Any name you can give. Whenever you are loading a file using Spark context, a text file, if you are loading, you can give any names for these RTTs. Here, if you want to persist R3, this is what the code you are going to write. And here, if you want to persist R3, the programmer only is need to say persist. Then R3 is going to be persist. Means whenever RTD4 gets loaded and computed, RTD3 don't remove it.
okay, it is by program, not that
Persist is a method.
method. Okay.
Okay, fine. Persist is a method, right? Using we are going to write programmatically. See, in the previous example, R3 in the RAM, R3 in the RAM, R3 in the RAM. In all the flow, all the 3 flows execution completed. All these 3 flows execution completed. Now, when all the 3 flows executed, right? Now you doesn't want all 3 also in the RAM. And see that all that, what all that flows you want to execute, everything got executed. Now R3 also, you doesn't want it within the RAM. Forcefully, you can unpersist it. Forcefully, you can unpersist it by saying R3 dot unpersist. R3 dot unpersist method is there. See, one thing, unpersist happens immediately. Unpersist happens immediately. It will go and remove that R3 immediately from the RAM. But persist won't happen immediately. Why? Persist won't happen immediately. Unpersist means immediately R3 gets unpersisted.
The memory allocation checks and all that needs to be done before we do persist.
Persist means first which one you want to persist? R3, right? R3, right? When, for example, if you go back to this, you want to persist this R50, you want to persist. When this persist will happen? When this persist will happen? When 49 first that R1, R2, R3, 49 RTD is loaded, 50th RTD, R50, now it is going to load. R50 loaded, computed, now it will be persisted. When, after how much time or after how many steps it will be persisted, means after, because directly it won't go to that RAM and R50 won't persist, right? That is not available first. When it will be available R50, after executing 49 transformations, After 10 RTD is loaded and they got removed from the RAM, whenever the first time R50 getting loaded into the RAM, at that time only it will be persisted. But unpersist means already the RTD which you want to unpersist already available in the RAM. Immediately it will go and unpersist. But persist, if you say R50 dot persist means that R50 is it available? To make it available only you are persisting, right? So when it will be persisted means whenever first time when it is getting loaded into the RAM, all its partitions getting loaded into the RAM, at that time only you can persist it. Until then. What is the advantage of persistence? So here R50 output can be used by R70, R90, R80. Multiple flows can make use that already executed. These are the 50 steps. The 50 steps output will be taken. So here you, instead of 70 steps, only 20 steps you will get. Hereafter, you will get less number of steps. 50 steps are decreased in all these things, right?
Sir, one doubt, sir.
Hmm.
When we say we are configuring 2T, I mean, when we have RDD of 2TB, for example, how do we configure it? I mean, is it auto-configured or auto-scaled? How does it work, sir?
Configuring what?
For example, we have one RDD instance for 2TB. So where do we configure that 2TB? I mean, we require 2TB of the space. How do we do it in DataBricks or do we do it in Azure? And where
Okay.
does that
Azure,
memory
Azure,
get consumed?
you'll do it in Azure, right? Because in Databricks, okay, it's going to provide the cluster for you. But your storage happens in the Azure storages are there. Generally, Azure Data Lake storage will be used. Azure Data Lake storage will be used. In that already your files are stored in Azure Data Lake or Azure blob storage, right? Already your data is stored in that. See, where is your file path available? Where is your file path available? Already your file is available in Azure, right? Whatever size it is. Just you will be giving the path of it. Whenever you give the file path using Spark context, this RTD gets loaded.
Sir, when it is getting loaded, I mean the cluster. So what when I'm somehow like for example, sir, we are loading the data, that is one part of it, and the processing also happens.
See one thing. Yes, I got your query. Whether you can check with this. So if you talk about this big data, is Hadoop or Spark, they have brought a revolution right in distributed computation. So here you will have got driver and worker nodes, driver and worker nodes, driver and worker nodes, right? Driver and worker nodes. This is called so this is your cluster. You have got n number of nodes. One will be the driver, remaining all will be the worker. So think that you have got some 40 nodes available here, 40 systems. Means you will be configuring it. You will be creating this cluster in the cloud. You will be selecting, okay, how many workers you want. You need to give that number, and what is the configurations you want, what is the RAM configurations you want, what are that processor, all the configurations you will be choosing, and you will be a cluster will be created. If any file, right, 2 TB file divided into partitions, each partition stored across multiple RAMs of multiple systems. In this way, how it is going to be executed within the Spark cluster level. All these worker nodes will be executing them parallelly.
Got it, sir. Sir, sorry, sir, I'm like trying. Where will RDD come in this picture, sir?
Where will be the RTDs? What is this 2 TB? It's an RTD, right?
Okay. So RDD is a file with a particular size.
So here you'll be defining like this. What is it? You give a file path. You are providing a file path. Using Spark context, if you load this file path, RTD gets created. RTD gets created, and this RTD is going to be divided across It's divided into multiple partitions. Each partition will be stored across multiple systems. And based on the business logic, right, we want to filter or map or grouping or sorting or whatever transformations you apply on it. Based on that, on the multiple systems, it is going to get computed parallelly. It is divided into smaller partitions. Whether it is got huge data size, they'll be divided into partitions and distributed and processed, computed parallelly. And the
Got it.
results are collected. Understood now?
Sir, please correct me if I'm telling it wrong. So if so RDD is a layer or something like a layer where we do the transformations and we also make the data partition happening. Got it. Okay, sir. Yeah.
RTDs, right? Resilient distributed data sets. Spark data objects are called RTDs. Means Spark data objects RTDs, and later in our course, right, we'll be discussing about the data frames. Data frames means you will see in a structure like a tabular structure you will be seeing. RTDs doesn't have any like schema or structure, but later data frames, RTD plus schema, nothing but data frame. Data frame is just like a table. So here initially Spark data objects, I'm saying RTDs are data frames. RTDs, how they are the first RTD, how it is getting created means a file from a file, from a file. First RTD created, later you will perform transformation, a new RTD gets created. Again, one more transformation, a new RTD. Every time the output, whenever you perform transformations, right, the output, it returns a new RTD.
Got it, sir. Got it, sir. Thank you.
That's right. So here RTDs are immutable in nature. They won't get modified. Here RTD1 dot filter means don't think this RTD1 getting modified. You are just taking its output, a new RTD is generated. But the original RTD, if it has got 10 lakh records, 10 lakh records will be there as it is. But from the 10 lakhs, filter only Hyderabad records as particular department records. Think that only 2 lakh records you are filtering. RTD2 will have 2 lakhs. This will have 10 lakhs original data will be there. A new RTD created. And from that RTD, you are mapping something on RTD2. Okay, you are mapping, okay, for each and every, for all that what 10 lakh, 2 lakh employees, add 5,000 bonus. You are mapping a transformation, a logic, a business logic. You are mapping for each and every element of this RTD2. And that transformation applied on for all this, and a new RTD3 is created. RTD2 will be there as it is, and it won't be modified. Once an RTD created, it won't get modified. It will be there as it is. A new RTD gets created, right? And later, as part of our course, we'll be discussing about data frames, like a tabular structure where you can perform many functions are there. You can see many functions which we can be applying on this data frames. So data frame functions. So once creating data frame, empty data frame, show, row, class, select, collect with column renaming, where, filter, drop, order by sort, group by join, union by name, UDFs, map, flat map for each sample, fill null, pivot, partition. In this way, you can apply many functions. People who have got knowledge in Azure Data Factory, there you will have got inbuilt transformations available. Here through functions only, many functions only will be performing the task. Their filter transformation in Informatica or in Azure Data Factory, for example, filter transformation, here filter function. Their derived column transformation, separate drag, you will drag it. Here derive, so here we'll have separate function. If a column rename or deriving a new column with column functionality is there. So in this way, by using its code based, so this is that course content we'll be discussing in brief. Azure Databricks, just you'll be getting knowledge on this big data, Hadoop before we go with this. And Spark architecture, Spark RTDs, Spark RTD data frames, basics of this cloud, Azure cloud. And coming to this Databricks, right? Databricks, that is workspace creation, cluster management, cluster creation, how to create a cluster, displaying clusters, starting cluster, terminating cluster, how to delete a cluster, cluster information, cluster logs, everything, how we can see and how we can perform all these things. Practical I'll be showing. Yesterday also I said, right, you people can do all these things, parallelly along with me. All these tasks, how to create a cluster, the things. If you got any error and any configuration errors, immediately you can share the screen and check that, right, immediately. No need to wait. So all this, I said, it's a hands-on where you people can do all the things parallelly along with me. There won't be anything theoretical, everything practical only. For first 3-4 days, right, you need to understand about this Spark architecture, this Spark data objects, how they are getting computed, how they are loaded into the RAMs, how they are get processed, right? That things you need to understand. Databricks utilities, data utility, job utility, library, notebook, Databricks integration with the different like data lake storage, Azure SQL, Synapse, Snowflake, right? And PySpark SQL data frames. This is the main thing we see in this PySpark, right? Data frames or RTDs with the schema we say it as data frame. So all these are the different functionalities we can apply. And PySpark SQL functions, aggregate functions, window functions, data and timestamp, PySpark built-in functions. These are the various PySpark built-in functions you can make use for performing different operations, right? And Databricks handling multiple file formats, CSV, JSON, Parquet, Excel, XML, ORC, Avro. Databricks batch processing, historical load, incremental load, aggregations, joins, windows, and PySpark external sources, integrations, narrow and wide transformations, adding, dropping, and renaming columns, handling nuls. Databricks streaming API and Databricks Lakehouse. What is Delta Lake? The features of Delta Lake. SCD type 1, type 2, data deduplications, workflows, and running and managing Databricks jobs, scheduling Databricks jobs, monitoring Databricks jobs. So in brief, in depth, we'll be discussing about all these things. So 2 months is the duration for this. So as I said, offerings from myself, you'll be getting each and every session video, you'll be getting soft copy of the class notes, assignments and tasks, work, and a WhatsApp group. It will be created. Tomorrow, a WhatsApp group will be created. You will be added to the WhatsApp group, everyone. And from tomorrow, you'll be getting the videos daily basis to your Google Drive. Daily one video will be added to your Google Drive whenever the session gets completed. From tomorrow onwards, the notes, clear notes, you'll be getting tasks to work with and hands-on sessions, right? So from the starting of that practicals, how to create this Azure subscription, how to create the data lake instance, that is Azure Databricks instance, Azure SQL instance, and configuring and how to work with all the things, right? You can do it parallelly along with me. Okay. So tomorrow the link will be changed. So you are supposed to get enrolled for getting the link to your mails. Fine. You can see in the chart, a big message is given by that online team. Or the course content details is provided, their contact details is provided. If you have missed yesterday's session, you can see the videos of it. But from tomorrow onwards, you'll be getting the videos to your Google Drive. And any concerns, their contact details, the payment details they have provided. And also they have given some comment, you can see that in italic form, right? If you have got enrolled, if you have paid that fees, right, don't forget to send the screenshot of that payment receipt for confirmation, right? Its transaction ID, so that then only they'll be forwarding you the link, right? Don't forget to send the screenshot of your payment to that mail ID that is provided, DURGASOFT online training @gmail.com. Then only, and people who got already enrolled with the Azure Data Engineering, they can attend directly, right? In that Azure Data Engineering package, you got this Databricks PySpark is part of it. Okay. Any other queries? So let me make it clear about the timings once again, right? Before first 1 week, it will be at 4 p.m. After 1 week, the sessions will be at 5 p.m. up to the end of the course. Make it clear about the timings. Any other queries? Fine.
One doubt.
Yes.
These partitions are automatically taken care by Spark only, right? The RDD partitions.
We no need to create. Automatically they will take care. But even if you want to control, okay, if you have got, if you want to control the partitions also, you can have that option. Whenever you are loading a file like this, right? whenever you're loading a file, by default number of partitions, Spark only will take care, divide into partitions, load into worker nodes and process. Everything happens in the background, right? Taken care by this Spark. But still, if you want to have more parallelism, you have got some 100 node cluster, but your data is stored only on 20 systems. But I want to store on more systems so that I can get more speed. In such case, you can give 20 here. Means this indicates that number of partitions you want. This file you are loading and RTD creating, but you want 20 partitions, you give 20. 30 you want 30, you can in this way while loading the file. But otherwise, by default, it will take care with default number of partitions. If you want to know that how many partitions got created, so for this RTD1 dot get num partitions, this command will give how many partitions got created for this. You can see RTD1 got, they get num partitions. This method will show that number of partitions, like for example, some 10 partitions created for it. It will give that. If you want to know, but automatically they get partitions gets created, everything taken care by the Spark framework. Yes.
And you said immutable. Let's say this RTD2 is immutable. So when it is get flushed out in the memory, again it is performing, right? So how it means the value
RTDs are immutable. Yes, RTDs are immutable. They are not modified.
Okay, they cannot be modified. Okay, but after let's say it get flushed out, means once RTD3 comes into picture, RTD2 get flushed out from the memory. So again it will be loaded, or what? Means in what way it is immutable?
See, 1 second. Okay, once RTD3 is computed loaded, it is getting removed from the RAM level.
Yes.
Whenever it is getting removed from the RAM level. But here RTD2.map means we are just mapping RTD2's output with some transformation and a new RTD3. Whenever you say RTD3, or if you want to collect RTD3, here after RTD3, if you say RTD2.collect means, will you get a modified RTD or original RTD2? After RTD2, I'm just want to say RTD2.action means RTD2 output, it will show you. Which output means this RTD2. If you say RTD3.collect means RTD3 output, it will show.
So again it will perform all this because no persist is there. So again it will perform.
Again, it will execute and it will give that output every time.
So can we means change it? Means let's say RTD2 is equal to again RTD2.map. So we cannot change it in that way, right? It is immutable.
You can change. RTD2, you can change like this.
Then it becomes how if it can be changed, then how come
here,
it is mutable?
Here RTD2.map means you are just giving the name, overwriting. RTD2 equal to RTD2. You can give these names like this.
Then immutable means if it gets changed means how it is immutable?
RTD3 generally, okay, RTD2.map, you will just create a new RTD3. You're not modifying it, right? You're not, see here, RTD1, RTD2, RTD3, RTD4, right? Just you are taking the output and you are just creating a new RTD is getting created. Yes. A new RTDs are getting created. You are not modifying them. They cannot be modified. Just RTD1.filter, whatever the output you are getting, right? A new RTD is returning. This is returning a new RTD. It is returning a new RTD. The output of this is a new RTD. Here also a new RTD is created. The original RTD will be the same. We are not modifying here. Every time a new RTD is there. See here, X value is 10. X value is 10. X plus 10 means you are not modifying 10 here. You are not modifying the X here. Sorry, you are not modifying the X here. If you say print Y, okay, Y value is what? 20 you will get. But X will be the same, right? 10 only. Hello.
Okay, what if we will write X equal to X plus 10?
here this will be x equal to x plus 10 means first this will be removed from the memory and new x will be created. You cannot have 2x.
Okay, in that way it is immutable. Okay, now got it. Got it.
Okay, fine.
Because system internally thinks it's a new transformation, means new steps, RDD. Even though you mention RDD2 instead of RDD3, system will think it is RDD2 only
Yes.
internally. Okay.
One question regarding the environment for the Azure DataBricks. Are you going to provide the Azure DataBricks environment, or we have to take subscription?
So Azure is providing some free subscription, right? You can make
Yeah.
use of the free subscription.
Okay. Suppose if I want to practice and take the Azure Database, how much it will cost per hour? Any idea?
Azure Databricks, you are saying?
Yeah.
See, Azure Databricks, okay, if you go with, there are two things. Free trial is there. Azure is providing free trial for 30 days. After that, you need to go with pay as you go. Otherwise, if you got another credit card with another mobile number, another email ID, mobile number, and credit card, you can get one free account. If you got one more, you can go one more free account. Otherwise, you can go with pay as you go. I'll show you with minimal, very, very minimal cost how you can work with Databricks. The thing is, Databricks, okay, it is will be costing you, but one thing, after you will be creating a cluster, right? You need to delete the cluster so that all the cluster and this background resources, everything gets deleted. See, I'll be showing you which things you need to delete so that it won't cost. Once your work today's practice is completed, you can delete the things. Which one you need to delete? I will say you. And again, tomorrow recreating that takes hardly 2 to 3 minutes. It takes 3 minutes it takes for recreating a cluster. So in that way you can work, you can with very less cost, you can work with this. Otherwise, your cost will be more only. Yeah.
Can we practice in community edition, Database community?
Community edition also you can work. It's free. Community edition is free.
But there we cannot use the storage of Azure, right?
In community edition, right? PySpark code you can execute and check the outputs, but all the things, full-fledged features you won't be getting. But PySpark code, everything you can work with where you can keep the data sets, everything. I'll be saying you in community edition you can work freely.
Okay.
Okay, fine.
Or is a demo session or
What is it?
tomorrow also there is a demo session or no?
Tomorrow, no domain session. Tomorrow onwards, you'll be starting with the actual things, right? So we'll be continuing from here itself, but tomorrow you are supposed to get enrolled. Yes.
And what is the which is in high demand, which AM or this PySpark,
What is it?
which has a high demand, this
Yeah.
PySpark or ADF?
See one thing, right? Yes. PySpark, PySpark is the main thing in all this data engineering side, right? Either if you're ADF, Azure Databricks, Azure Synapse, in all this, PySpark is the main execution engine. For all this execution happening by using Spark only. At the background for ADF also execution happening by Spark. Spark is executing in Databricks, Spark execution, Synapse, and all these things, Spark only. Spark has got great demand in today's industry, right? Even if you have got good command, see a lot of you can see the salary packages for this Spark also, right? Huge, like 1.5 times other than the other technologies, right? So it's a good technology. It's you can expect, you can demand for this salary packages also, right? For this. So we'll be discussing, I said, you can see the course content in brief, in depth, we'll be discussing about all this PySpark Databricks, right?
Okay, so this PySpark with the Databricks is like fine to get the job, right?
Yes.
Or do we need the ADF for whole?
If you got
Okay.
time, if you got a time to update also, you can also update with ADF. ADF is like a data, what we say, ETL, it can is a kind of ETL, right? ETL, extract, transform, and load it performs.
Yeah, yeah.
It acts as a data integration service. Even if you have got, but this is also fine. If you can go into that, you can step into the company as a ADF developer, Databricks developer, the data engineer, you can go. But the salary package will be high if you got knowledge on this PySpark with DataBricks as compared to ADF. Even if you got all those things, right? ADF for DataBricks, that is fine, much more fine. But you can step into the company using this DataBricks developer.
Okay.
Yes.
So in CV, what we have to mention, will you be telling at the end of the course what?
Yes, yes, I'll be showing you at the end, right?
And interview questions, key interview questions.
Yeah, yeah, interview questions, those things, interview questions and resumes I'll be forwarding. Okay, fine.
After this course, which designation we can apply for? Position developer, database
PySpark,
developer.
PySpark developer, you can go.
Okay.
So this class duration will be 1 hour only, right?
1 hour. Tomorrow, same time, 4 o'clock only. For the next 1 week, it will be at 4 o'clock. Later, it will be at 5. Okay, fine. So if I'm done with the queries, if there are no other queries, I'm signing off for now. Meet you tomorrow, same time at 4 o'clock. So tomorrow there is a change in the link. Check with that. Thank you all for your time. Thank you. Meet you tomorrow.